thing that is fairly difficult with algebra in general is the amount of rules and all the different processes that we have. Okay, so what we're gonna do is first we're gonna talk about like a couple of the properties. Okay, one of the properties that we have is a distributive property. And a distributive property is whenever you take a term that is touching a parenthesis and you distribute it to every single thing inside of the parentheses. Okay, so I'm going to do a very general, like abstract, not expression, but an example to show you what I mean by this. If we have a term, anything in the world, it doesn't matter, it could be a 2 or a 3, and it's touching a parenthesis that also has some terms inside of it. And I'm going to write right here, like this would be something like this. Okay, I'm going to show you first in this abstract way, and then we're going to do this little example I wrote in blue. Okay, I'm going to do that blue example after the abstract one. Okay, so what you do whenever you have something that's being distributed is you're actually going to take and multiply it to everything. I know that it's multiplying these two terms inside of the parenthesis because there's nothing in between right here. There's not a negative sign, a minus, a plus, there's nothing. It's just something touching a parenthesis. That means multiplication. Okay, so the thing is, it's not just multiplying one thing, it's multiplying whatever's inside of the parentheses. So what you're going to do is you're going to take that term and you're going to multiply it to everything. What ends up like tripping everybody up is this little symbol right here in the middle, whether it's plus or minus. A lot of people will have that confuse them. What matters is whatever's on the inside is being multiplied by this. There's other rules that go along with that because we're in algebra and there's rules for everything. Okay, well, let's say we were to do this. We would take that A and we would multiply it to that B. Okay, the way I'm going to show you in this abstract form is if things are touching, they're multiplying. So I'm just going to write AB. That's me multiplying the A times the B. After you do that first multiplication, now I'm going to do the exact same thing with the other term. Okay, so if I take the A, I'm now going to multiply it to the C. Okay, now because I noticed that I have that plus sign, I could write that right there. That's very abstract. It's supposed to be as logical as possible. Algebra says what it means and it means what it says, but it's also confusing as hell. Okay, so now I'm going to give you like this little light blue example. Okay, so you can really see it's the exact same thing. The abstract is just to tell you it doesn't matter what numbers you have, what letters you have, what variables, it doesn't matter. The process is still always the same. Okay, so can y'all see that blue? Yeah, kind of fairly good. Let me, what I do, 2x plus 3. So now let's say this. So like this would be like an actual example right here of us looking at this distributive property. I'm going to swipe up, okay? I wish I could move the marker thingy away. Say we have 2 open, and then I wrote x plus 3. If you notice, it's like the very same type of format, but now I'm saying like, hey, this is an actual equation. This is a part of something that we're working on. It's not abstract, meaning one way to look at something, but it's not specific, right? This right here is specific. Okay, now I notice that I have a 2 and then a parenthesis. There's nothing in between the 2 and the parenthesis, so that tells me this is multiplication. Okay, but there's multiple things inside of the parenthesis. So what I need to do is first, I'm going to multiply the 2 with the first thing inside of the parenthesis. So if I do 2 times x, what happens there is it just becomes 2x, right? Because you're just multiplying them together. So I get 2x. And then what I'm going to do is I'm going to multiply the 2 times the 3. This, and I say it every year I've ever taught college algebra. This is going to be where people mess up, even though I tell them don't mess up here. If you look at that abstract, right, I didn't write over here A plus C, right? I multiplied them. If they're like kissing or they're touching, that means they're multiplying it together. So I'm going to do the same thing. I'm going to do 2 times 3. And then you kind of look at the sign. Is it positive? Is it negative? But if we do, yes, it was Jacqueline or somebody said 6. Yeah, 2 times 3 is going to be 6. And in a second, I'm going to go over my little sing-songy things that I use to remember when you're multiplying or adding or dividing, like what do you do with the sign? But right here, if you can just think about the fact that that 2, not obviously, but hopefully you see that it's a positive. If it wasn't positive, there'd be a negative sign in front of it, right? And well, there's nothing in front of it. So it's telling you, hey, I'm positive. If you take a positive and you multiply it to a positive, you get a positive. Okay, so I end up getting a positive 6. What I will see on the exam, I guarantee you, even though I say don't do it, is everybody will take that 2 and they'll multiply it to that X, right? And then what are they going to do? They're going to look at that 2 and then they're going to look at the plus 3 and then they're going to write 5. They're going to add them together. They're not going to multiply them. Okay. But if I have something outside of those parentheses, you're multiplying it to everything inside. Don't care about what the signs are until after you do that multiplication. Okay. So that right there is just the distributive property. And it can be something that can be complicated, but you'll see 5 of these in one problem. You know what I mean? Like, so I'm trying to ease you into it, but y'all know how these homework problems end up getting. Okay. They get kind of gnarly. Okay, so now let's talk about what it means to be an additive inverse. I'm going to swipe up. Okay, did I do a colon? I did. I don't know why, but I did. If y'all help me keep up with like grabbing these links, maybe I could do like a module on what's it called, on Canvas, and then like I could put these links for this like whiteboard. And I think as long as you're using your TVCC email or something, you could actually access like these notes that we take in class. Okay, I just don't have a memory, so you have to remind me sometimes. Okay, an additive inverse. So additive, everyone should think of addition because obviously like it's kind of a derivative of that, like it comes from that word. And then inverse, when you think of inverse, a lot of people think of the opposite. Okay, so it's literally saying if you take and you add something to the opposite of itself. Okay, that's what this like property means. It's an additive inverse. So I'm going to do like I always do. I'm going to show it to you in an abstract way, and then we're going to do an example. Okay, so the abstract way would be, let's just say we have some letter and let's make that letter A, right? And that letter, it could be whatever number, variable, or anything. And I have this term right here. And what I do is I add the opposite of a positive A would be what? A negative A. And when you kind of, if you do like a positive and a negative right next to each other, you have to do those parentheses. Because if not, like even your calculator will tell you syntax error, like you break math. Okay. So if I know I'm going to add a negative right here, and believe me, they'll do everything in their power to make it look as confusing as possible, just to see, do you understand what you're looking at? Do you know what you're doing? Right? So if I have a positive A and then I add to it a negative A, if you think about math like money, sometimes whenever the numbers are really small, it's easier to do that. But if I have $5 in the bank and then I spend or take away $5, I'm going to have none dollars. Right? And it's because I used a positive 5 and a negative 5. Same exact, like the A's mean they're exactly the same, right? I have the same exact values with different signs. It's like they 86 each other. They make each other go away. So what I get is 0. Okay? And then let me show you, like what I said right here. Say we actually, instead of making it abstract and instead of just using these letters, which I know can be confusing, let's actually put numbers to it. My favorite number is 6. So we're going to say, let's have 6. And then I'm going to do an additive inverse. I'm actually going to make this property true. I'm going to show it to you with a real number. So I'm going to add to it the opposite of a positive 6, which would be a negative 6. And if you do it this way, do you see how it's like, hey, that's that whole bank example I'm saying. I have $6 in the bank. Then I go and I buy me that really big monster and some hot Cheetos. That's basically my lunch for the whole entire day, right? It costs $6. I now have $0 in my bank. I have none dollars. Okay, so it's taking the inverse of something, which is like the opposite, and I'm adding it together. Okay, so even if you did like x's, if I had a positive x plus a negative x, hey, those are additive inverses, they go away, right? Let me see. I'll do that one right there. Awesome. Because we will see in obviously algebra a lot of x's and y's and stuff. And within a within a equation, we could see something where maybe it says y, and then you also notice that somewhere there's a negative y. Those are still just some kind of term. We might not know what it is. We could be solving for y. Regardless, if you see the exact same thing with different signs, they go to zero. Okay. 1 million minus 1 million is zero. So what they're doing here that they're not telling you, because I think they obviously want to try to confuse people for some random reason, is they're adding that plus sign. Y'all, if you make this row by column, if you make this column go away, a minus a, oh, I knew I was gonna touch it. A minus a is what? 0. 6 minus 6 is 0, right? So the confusing part is the fact that they're doing this plus sign and then this negative sign. So if you need to kind of not see that, don't see that. Okay, it's just to kind of teach you that if you have a positive y and a negative y somewhere, well, they're probably going to end up canceling each other out. Okay. Okay, so do we see that one? I think I said this last time too. I think that one was later. No, we're going to do both. We just gonna do our thing. Okay, so let's do a multiplicative inverse. So additive inverse, you think of like add, right? You like add like addition. Multiplicative, you should think of multiply, right? Something to do with multiplication. So it's telling you to do the opposite of multiplication. The opposite of multiplication is division. Okay, so multiplicative. And all of this is just kind of building up to, that's not how you spell inverse, Jennifer. How to do an actual equation. I think I've got the bottom half of this page, and then we're going to jump into the examples. Not even gonna lie, they're gonna be the exact same examples that y'all have in y'all's book from last time. Okay, but you know, we're gonna see them more than once. Multiplicative inverse. A multiplicative inverse in a very abstract way is saying if I have some term, and I just keep using a, so we're just going to keep using a. Okay? If I have some term and I want to try to find a way to make this term equal 1, this is how they're going to show it to you. Is if you use the reciprocal of it, which means to flip it, and you multiply them together. Okay, now I'm gonna kind of break this down in an intermediate step right here using this blue color. What happens here, if I multiply things together, I just would multiply the top times the top and the bottom times the bottom. That's how you're gonna multiply fractions, even though stuff doesn't really look like a fraction. If I do a times 1, I get a, right? And do you see how there's like an invisible 1 right here, y'all? If I do 1 times a, what do I get? A. What is a divided by a? What's 2 divided by 2? 1 million divided by 1 million. Anything divided by itself is going to give you 1. Okay. I'm going to kind of delete those right there because I'm going to do an example. Okay. If y'all wrote them, that's fine. After you write a over a, then write equals 1. Okay. Oh, I did all these little dots. Okay. This right here is going to be a over a, which is going to end up being 1. So if you have an additive inverse, you notice how we always went to 0. Okay. If you do a multiplicative inverse, or if you ever see like a fraction, you're never going to end up turning any fraction into a 0, but you can always turn it into 1. Okay. And here would be like putting numbers to it. If I take my other favorite number, y'all should know what it is. If I take 13, and I need to figure out how to turn this into a 1. The only way you could take a number and turn it into 1 would be to divide it by itself. Okay. So if I divide it by 1 over 13, and I know that it's kind of doing too much sometimes because it's like, why not just write it over 13? Okay, but these are properties and I'm trying to be as proper as possible while like explaining it as much as possible. Okay, now if I was to do this and I multiply top and bottom, I get 13 over 13. And then if I do that, I get 1. Okay. So that right there would be something that we might see, even if I just say to you, hey, I need to do a multiplicative inverse. Think inverse is opposite. And then multiplicative, such an ugly word, is multiplication. What's the opposite of multiplication? We're trying to divide by something. Okay. Okay. I've got one more little property and then a couple of little like notes that I always try to give algebra students because I know like how I teach and how I say things. And so I want y'all to be able to like go back and read my notes if what I'm saying isn't making sense. If you don't want to just ask. Okay. Okay. So one more is the zero product property. Okay. This one, y'all, I don't know if you remember, but we end up seeing a lot in like chapter 3. Whenever we're doing like the parabolas, even, I mean, like we see it a lot. It's so much. And like I said, math means what it says and says what it means. Okay, zero and then product. Zero, we're gonna literally have a zero, like, sorry, that freaked out. We're gonna literally have like something set to 0. And then product means that something's gonna be multiplied to itself. Okay, and this is what it looks like right here. If we have, and this one actually is a little bit fancier, it starts with if we have two things multiplying itself, I'm sorry, each other, and then set equal to 0, and this is how we're gonna write it, A and B. And all that means is it's two different things. Moving forward, it ends up being like the parentheses of like x plus 2, and then over here is like x plus 3, and right. But the thing is, if you put it as simple as possible, one can be called A, one can be called B. Right? It's just two completely different things multiplying themselves, and it's set equal to 0. Then, so if we have this, then we can do this. What I would always say in the past is, hey, we have two things multiplying each other set equal to 0. So what that means is set them both equal to 0. So here you take A and B, and you set them both equal to 0. And then I don't want to do one that's like too complicated, because moving forward, it will get more complicated. But as far as our blue example is going to go, we could say something like if, well, I can actually go as far as like solving it yet, but I just want to like have an actual example. Okay, because this is something that we have seen in the past. Obviously, it's going to step up a level of difficulty, right? But these are two different things. They're not the exact same, right? So let's say that this x plus 3, that's my A. And then the x plus 2, that's my B, right? If I have those two things, they're multiplying each other, right? Because the parentheses are touching. There's not a sign in between them. So if these are two things multiplying each other and they're set equal to 0, what I can do to actually solve for these x's, because that's all we do in this class, is I can take one of them and set it equal to 0. And then I can take the other one and set it equal to 0. And that kind of sets up like two little baby equations, and then you solve for your x. Okay, so this would be, then we could take that first one and set it equal to 0, and we can take that other one and set it equal to 0. I'm gonna swipe up, y'all. Okay, so that's taking that abstract and then me just kind of showing you right now, this is what it means. Okay, and then in an actual problem, if we did have something like that, it would want us to know, hey, what are these x's? And we would just kind of, we would solve for them, right? Okay, so let me see. I've got 1, 2, kind of like 3 more little things, 4 more actually to explain, and then we're going to do an example. Okay, so let's talk about combining. signed terms. So combining just means I'm either going to be doing addition or subtraction. Signed literally just means one might have a positive sign, one might have a negative sign, right? They're terms, they have signs, and I'm combining them together. Okay, excuse me. Okay, so if okay, if signs are different, you subtract values and keep the sign of the larger value. Now, I know I talk a lot because it's kind of my job. I also know I could be very annoying, but this is something I would always say. Signs are different. Subtract, keep the sign of the larger, right? Like that's something that I will say literally for the rest of the semester because we will see it all the time. Okay. And an example of that is something similar to -7 plus 3. Okay. Somewhere in an equation, I guarantee it, we're going to have to, move x's over here, move y's over here, whatever it may be. Then it's like, hey, now combine the like terms. Well, these would be alike in a sense, right? Because they don't have variables. But then that's whenever now it's like, well, they all have different signs. What do I do whenever things might have different signs? Here, what do I say? I say signs are different. So what does it say? Subtract the values. Don't look at the signs, just look at the numbers, right? If I do 7 minus 3, right? Or I take 3 away from 7, I'm going to get 4, right? And then after you do that subtraction of just the values, keep the sign of the larger value. The 7 is the larger of the two values. So that 4 is going to be. So then whenever I'm doing equations and I'm like, okay, hey, these don't have variables. They're alike. What do I do? Okay, signs are different. Subtract, keep the sign of the larger. Okay, I will say that over and over and over again because it's just going to be like the most prominent thing that we do, right? And then let's see, what if we were to, you could even write it in a different way. Like let's say we did, I don't want to do that one because that one almost seems like, well, we're gonna do it anyways. This one, I don't even have to ask y'all what this answer is. Doesn't everybody already know what 6 minus 5? 1, okay? But look, don't they have different signs? That 6 is positive, that 5 is negative, okay? So no matter what you're doing, if an equation's big, don't think about, anything other than what I'm saying. Like signs are different, so I would subtract, keep the sign of the larger. So the reason why I did that is because maybe the negatives might not always be in the front, okay? But it doesn't matter. If you see two things and you're trying to combine them together, if the signs are different, subtract from the values and then keep the sign of the larger, okay? Now let's talk about if the signs are the same. Okay. One way of this little second chunk right here is fairly understood and no one questions it. It's the other way with the negative numbers that people get confused. But if the signs are the same, you add the values and you keep the sign. So the one that, not the one, but like the way that this can be presented to you that's never questioned, like ever, is like 13 plus 3. What would 13 plus 3 be? 16. But what I see is I see two terms, right? What I notice, they have the same sign. So signs are the same, add and keep, that's a positive 16, right? No one thinks about that one, obviously, right? Because that one's like very or fairly easily understood. You know that you have a positive 13 and you're adding a positive 3, you get a positive 16, right? The one that people will like overcomplicate or think too much about, and then all of a sudden they feel really lost, would be if the signs are the same, meaning both negative, right? So if we have like that, a -5 and a -7. If I'm working within an equation and I know that I've gotten to a point where I need to combine the like terms, and I see these two numbers that do not have variables and I'm going to combine them together, what I notice is I have a -5 and I have a -7. Okay. The other thing I notice is signs are the same, right? The rule for signs are the same is is add and then keep the sign. Right, and if that right there doesn't make sense to anybody, y'all could ask me. It's very similar to the other example earlier. If you really think about it, if I have -$5 in my bank and for some random reason they let me go and buy lunch, right? And then I'm gonna add more negative, I end up getting a larger negative. Okay. The other way to see this would be how we did the additive stuff earlier. There is this like kind of invisible plus sign there. It's -5 plus a -7, okay? But usually you won't see that plus. You'll just see a bunch of negative numbers next to each other. If they all have the same sign, add all the numbers together and then just keep that negative, okay? Okay, two more. Okay, so with multiplication and division, we have two different things here. We could have the signs being the same, or we could have the signs being different. Stop. That was from earlier when the big screen was making noises. Okay, I wish I had my other notes. I grabbed this one because it was more thorough, but it's all messy. If signs are the same, you have a positive product or quotient. Fancy words, honestly, for no reason other than to say that if you have a product, you just multiplied two things together. If what you get as an answer is a quotient, it's saying you divided. And I'm going to do an example of both. Whenever you're multiplying things together, you look at the numbers, multiply the numbers. If they have the same sign, then your product, right? The answer to that multiplication problem is positive. Okay. If you have two numbers or two terms dividing, after you do the division on the numbers, you look at the signs. If they're both positive, then you have a positive quotient. It goes the same for if they're both negative. Okay. And that's because we all know negative times a negative is a positive, right? So what did I do there? I multiplied things together. They had the same sign. So I got a positive answer. Okay. So if we have like a -3 times a -2, and that's what I mean, like first, and y'all should remember some chunks of it, but if I do the multiplication with the numbers first, and then I look at the signs, 3 times 2 is 6. Signs are the same, so it's positive. Okay. Same thing, 5 times 5, right? Both positive. If I have 5 times 5, I get 25. They're both positive. My answer is positive, right? And I'll go ahead and do that too. 5 times 5 equals 25. So the first right here, they were both negative. The second one, they were both positive. What I'm asking you to pay attention to is if they have the same signs, you get a positive outcome, right? And then I'm going to switch to purple just so we could do the division in a different color. If we have a negative 15 divided by a negative 3, if you look at the numbers first and perform that operation and then look at the signs. 15 divided by 3 is 5. Signs are the same, so it's a positive 5. Okay. And then are y'all good? If I do 21 divided by 7, you get 3, right? Like if they're both positive, we're good with that. It's the negatives that sometimes can get like a little blurry. Okay, now let's write the notes for whenever the signs are different, and then we can actually do an example. Okay, and then you'll help me keep up with time. It's 8:50 right now. Okay, so, oh man, I'm gonna do this because if I do give you all the links to this, I keep writing my ifs in purple. If signs are different, you have a negative product or quotient. It is so hot in this room, y'all. I'm gonna bring fans. Ice y'all out. So literally, if you notice, I can't spell quotient. How do you spell quotient? All of a sudden, my brain just went blank. What? Oh yeah, the T's first. Quotient. The exact same sentence, right? The only thing that changed was if the signs were different. Now we have negative, like answers. When the signs are the same, we have positive answers. And like I said, there's so many rules. So y'all just take good notes, and I'm always here if you need to ask me anything. Okay, so now we're dealing with different and it's negative. It's hard to just come up with random numbers, y'all. If we have 26 divided by negative 13. 26 divided by 13 is 2. Signs are different, so it's negative. Okay. That makes sense? Yeah. And say we have, I keep looking at my paper, there's no numbers. Isaac, I need a number. Give me a number. Nah. 14 times what? A small number. Let's do a negative 2. Okay. Now say we do 14 times a negative 2. Okay. If we're doing multiplication or division, it doesn't matter. Do that math with your numbers first and then pay attention to your signs. Here, 14, I totally like ran out of room, y'all. 14 times 2 is 28. Signs are different, so it's a negative 28. Okay. And these are all tried and true. Okay. If you pick up your calculator, I've taken an exam before and added like 5 and 6. It doesn't matter. Did multiplication with 2 and 3, whatever it may be. But if you kind of start to notice that these are patterns, this is something that you can use and memorize and learn, and it can help you so that you're not so reliant on your calculator, because if you make one mistake here, you think you're doing something right, and then you notice in the end you get it wrong and you're like, I don't know how I got it wrong. Right. So I have those right there to kind of just like help you. Let's do an example, like an actual legit example. All ready? Oh, what's your name? Slade. That's a really cool name. Ooh. Okay. I'm done. I give up. I just knocked over everything in one fell swoop. Okay, it's spilling. Oy. Okay, gotcha. No, we are not marked, not here. Okay, example. And don't get me wrong, y'all, like obviously this is math, you will need your calculators, right? Like even doing some of the equations and stuff, because they could have bigger numbers that you can't just do off the top of your head. But for the most part, like y'all should know those rules fairly well, okay? Especially moving forward, because y'all know how much we keep seeing like all of this beginning stuff towards the end, okay? So directions, usually just say solve. They're not really going to tell you. If they did tell you, look at this problem, do the distributive rule and then the associative rule and then the additive inverse, and then like it's just going to be too much, right? Your goal is just to solve for whatever this unknown variable is that you end up seeing in your problem. And remember, we're not finishing 1.1 today. So don't worry about opening up your homework. If you want to open up your homework, you could probably do about half of it. Okay. But if you don't have to, I mean, it's up to y'all. I don't want y'all to open it up and then freak out and like give up. Okay. Because there's going to be things we have not gone over yet. Okay. So solve. 5x minus 3 equals, or 5x negative 3 minus negative, they're synonymous. They mean the exact same thing. And y'all, I'll interchange them, like just because it's habit. And we're going to set this equal to 14x plus 6. All it says is solve. I know this is an equation because there is an equal sign. Okay, it has to have an equal sign to be an equation. What I see is one variable. In this class, we will only ever see one variable. You don't see multiple ones and have to do anything too crazy. Right here, I see one variable and it's an x. So it tells me to solve. It wants to know what value, like what numerical value does x have to be for this to actually be true, for this left-hand side to actually equal this right-hand side. And the way we're going to do it, it's a balancing game. You take whatever you can and you move things around. Whenever something moves from one side of the equal sign to the other, the signs end up changing. But what we're going to do is each individual step using the additive inverse, and then any of the kind of like rules or properties that we've learned so far for the last hour that I've been talking. Okay. So if I do that, the first thing I would do when I looked at this, I would look on the left-hand side. Can anything be combined? Do I see any type of example like we were doing earlier whenever we were adding things or subtracting things? Right here, you see where it says combining like sign terms. Do I see a -7 and a 3 by itself on the left-hand side that can be combined? Or do I see anything at all that is considered like? And I don't. I see the 5x and I see that -3. Okay, it is very important that you'll understand that's a positive 5x. Okay, that is one term on the left-hand side. And then the other term on this side is a -3. That negative stays with that 3. Okay, it's not separate from it or anything. It is a -3. Okay, and the reason why is because those aren't alike. So I'm not actually subtracting 3 away from that 5. Okay, they're separate. Okay, so when I look at those two things, they have nothing to do with each other. They're not common. So I can't like smush them together. I can't combine them, can't math on them, can't add them, can't do nothing. I go to the right-hand side. And I notice the same thing over here. I have something with an X and then I have something without an X. Can't do nothing there. Okay. If my goal is to get X equals a number, that's my goal, right? That's my answer. My answer is X equals something. Okay. I need to use what we just learned to kind of move things around, keeping everything balanced. Whatever you do to one side, you have to do to the other. Okay. So personally, if I can, I always want to try to have my X on the left. It's okay if it's on the right, but personally, like I always want to try to make my X to go to the left. So let's do that. If I know I want my X value on the left and I see that I have this X value right here, I want to move it. The way we move things in an equation is to do those additive inverses. And what was that? Inverse means what? The opposite, right? So if I think about needing to, this is a positive 14, right? The opposite of positive would be a negative. If I think about needing to subtract from this and make it completely go away, what is the number that I need to subtract? Okay, but I also need to include that X because they're together, right? It's not just 14. That X is a part of it. And y'all, this is a lot of things that get left off is I'll remember to do the -14, but then I won't do the X, and the X say like, just remember that they're together, they're touching, right? They cannot be separated yet. It's like the very last step you do is separate a number from that X. Okay, so here I'm going to do the opposite. I want to move that 14X over here because this is my goal. Well, it's positive. The opposite is negative. And then what I do to one side, I have to do to the other. Do not write it underneath here. They're not the same. You can't write it underneath this one. I need to write this X term underneath this one. So whatever I do to one side, I have to do to the other. So it kind of looks like I've just written a bunch of stuff and I haven't made any sense yet. And that's because once I figure out what it is that I'm moving, now from left to right, I'm going to actually do the math and see what happens, right? I know this 14x, I'm trying to turn it into a 0. So hopefully that's what happens because that's my goal. Starting from the left though, and y'all, there's no, I teach math and I still suck at addition and subtraction sometimes. I want to say 9. Yeah, it's 9. Sorry. I've had no coffee today. Okay, so starting from the left to the right, what I notice is I'm combining these numbers together, like the 5 and the 14. The signs are different. So when signs are different, what I do is I subtract and I keep the sign of the larger. TBH, I grabbed my calculator. I needed to make sure I knew exactly what it was. And it told me a -9. Okay, and now the thing is here, and I will, whenever we come back on Monday, I'll explain a little bit more here when we kind of start dealing with the variables, because all I've really shown y'all today is just kind of like the numerical values, just numbers, 15, this and 17 and 14 from Isaac, but I haven't actually like really explained the variables yet. Okay, so I will on Monday. But whenever we do addition or subtraction with variables, we just keep them. Okay, so the numbers I can do math on. And then 5x minus 14x is just -9x. And then I'm done with that. Okay. This purple third line is like my new line. This -3, do you see how I haven't touched it at all? It just comes down. And then Isaac, what happens when you take 14x and you subtract 14x? It becomes, it just went away. So the only thing left on the right-hand side is the what? The 6. That's it. And y'all, if you want to write it over because it kind of looks nicer or neater, you can. I'm just going to put it right here. And honestly, I'll probably just swipe up and kind of hide what I'm doing or just kind of just do it line by line by line. There's going to be some gnarly problems on the homework because obviously it wouldn't be algebra if there wasn't. And I'll make sure that I grab one because it's gonna have a bunch of like brackets or parentheses, a whole bunch of distribution that we'll do together. Okay, so this is where I'm at right now. If you notice, it's called isolating your variable, right? If you notice, I've almost like started the beginning of isolating this variable. Isolation meaning it's alone, it's by itself, right? I only have x's on this side, but what I notice is I don't have only x over there. I still have other things going on. Okay, now I don't want to do anything to this x because I just moved it over there. Okay, what I want to look at is moving whatever does not have an x away from that side. Do the exact same thing, like second verse, same as the first. If I want to move this -3 to the other side of the equal sign, I'm going to use the additive inverse. So what is the opposite of like that -3 or subtracting 3? Adding 3. And what I'm going to do is I'm going to put it right underneath it. And then what I do to one side, have to do the other. So I'm going to write a +3 over here as well. And then I'm just going to read things like I do a book because it just seems to always be the easiest thing. If you're going to keep in line with like doing every single step, very tedious, but who cares? If you get the right answer, it's worth it, right? So starting from the left, I have a -9x. I've literally not done anything to it in this step. So it's just going to be brought down. Okay. So this has not been touched. And I did kind of just scooch over a little bit on accident. It wasn't on purpose, but sometimes you don't have the ability to keep everything perfect because y'all know how crazy these problems get. Okay. And then now if I do -3 and then I add 3, I'm going to get perfect. I'm glad that happened because I'm very intentional whenever I work with equations. I have to be. I have a goal. I can't break math and like whatever I need to happen, I need it to happen. And what I needed to happen right there just happened. I bring down that equal sign. Y'all, if you do the line to keep it equal, that's fine. Okay. Over here now on the right-hand side, what do I have? Which makes 9. And you don't really see it, but it's the same thing. Signs are the same, add and keep. These are both positive. Add them together, keep their sign. Okay, now right here, this last step is where you're going to actually separate a number from this variable. This, believe it or not, because it didn't make sense like at the beginning of class, is using that multiplicative inverse, right? The easier way to say that, because that's a very annoying word, is to say, what is the opposite of multiplication? Division. Okay, so what you do is if I want x equals a number, right? And I notice that I don't just have one single x, but I have negative 9x. I want to divide by everything that's multiplying this x. And everything that's multiplying this x is not just 9, but negative 9. And the reason why is because I know that if I do 9 divided by, if I do negative 9 divided by 9, signs are different. I'm going to divide and then I'm going to get a negative. I don't want a negative x. I want a positive x. So I need to make sure that I make those signs the same. Do I have a lasso? I never know if I do this right. Obviously not. Go away. Okay, so I'm going to divide by everything, not just the 9. Make sure you keep the sign because you want to end up having one positive x equals a number, right? So what you do to one side, you have to do to the other. And then kind of like how I was saying a second ago, always look at the numbers first, then look at the signs, and then just don't forget your variable. Okay. What I have here is 9 divided by 9 is 1. Signs are the same, so it's positive. And we'll talk about this on Monday, but x divided by nothing is still just x. Okay. And y'all, if you write the 1 in front of your x, I don't really care. It doesn't bother me. Just know that usually moving forward, I won't, because just out of habit and because you don't really need it, right? If you have an x, obviously it exists. So there's that positive 1 in front of it. It's kind of implied that it exists there. Okay. And then you have your equal sign. And then we have 9 divided by 9 is 1. Signs are different. So it's a negative 1. And then just to be honest with y'all, this is how I would write it. I'm not saying you have to do this to get all the points. No, if you have 1 x equals negative 1, that is literally the exact same answer. I just think this is more proper kind of moving forward. So kind of not need that 1 in front of it. Then what this is saying is that if I go back to the original equation and I let x equal negative 1 and then kind of solve it, watch what happens. If y'all want to write this, you can. If you don't, it's okay. But okay. So now we're going to let x equal negative 1. I'm plugging it back into the equation. This is why it works. This is why we're doing it to begin with. Monday, we'll learn we have multiple different types of equations. You could solve something, get a contradiction. You can get an identity. You could have, Jennifer Nicole. I started thinking about something. Conditional. So you have one where it's it works for all numbers, one where it works only for one number, and then one where it basically lies to you and says 2 equals 3. Yeah, well, that's not the truth, right? So watch, if we do this, I have 5 open, negative 1 close, minus 3 equals, I'm literally writing down this problem that we just did, but instead of writing that x variable, I'm using my answer and I'm changing it to what my answer was. I'm going to see what happens here. 5 times 1, y'all, is what? 5 times 1 is 5. Signs are different, so it's negative 5. And then I have a negative 3 equal. 14 times 1 is 14. Signs are different, so it's a negative. And then what do I have coming down right here is a positive 6. And then now I have negative 5 and a negative 3. Hey, now I'm at the point to where I'm adding or subtracting. I've always called it combining. What do? 5 and 3, signs are the same. So you add and you keep. Okay, and if y'all want me to show you how to do it in your calculator and it not tell you that you just broke the calculator, I can. Okay, because there's that invisible hidden plus sign right there. And you have to make sure you use the right negative. Okay, I can show y'all that. Okay, so I just want to do this right now because I like it better. 14 and 6, those are signed numbers. They happen to be different signs, right? So if the signs are different, what you do is you subtract and you keep the sign of the larger. So on the left-hand side, they were the same. I added them and I kept. The right-hand side, they had different signs. So what you do is you subtract the numbers and you keep the sign of the larger. And then if you wanted to use your calculator, let me see, do I have this turned on? I'm gonna show you just in case someone does get to hear, because if I start getting certain looks, I want to make sure I clarify things. The amount of rules that exist in this class are insane. So I will go as slow as I can for as long as I can. I just broke something. Ooh. What's using my camera? The Zoom? Probably. Boom. I don't know if you're gonna actually be able to see this, though. Which way's right? Like that? Okay. So with the -5 and the -3, right? It takes a long time to learn the rules and like say it in your head. That's okay. That is a negative sign down here. This is a subtraction sign. Okay. So if something leads with that sign, you have to do this button. You don't start with this one. It'll tell you there's an error. Okay. This is a -5. And then I'm combining it with a -3. If you just do -5, -3, it tells you there's an error. Okay, but if you do -5 and then I'm gonna add a -3, you get that -8. That makes sense? The right-hand side, you can do -14 plus 6. Okay, and so there's even rules too with how you put things into the calculator. So if y'all start getting errors or something doesn't make sense, let me know. We still have 5 minutes left. I mean, I actually was fixing to let y'all go, but let me let y'all go before y'all let yourself go. Okay, y'all are free to go. Does you have questions? I will see y'all till next week, right? Okay, so I'll see you on Monday. Okay, I want to show you something. If you want to sit right here, I'm gonna pull up the canvas and just like 5 minutes, kind of talk through how to access like the online homework and stuff. Yeah. Okay.